Okay, so in this video, we're going to be designing and simulating a gumball bending machine controller that only accepts nickels and dispenses a gumball of a random color when 15 cents have been deposited. And so first off, we're going to start off with creating a state diagram. And this is how it should look like right here. It's only going to be three states, 0, 0, 0, 1, and 1, 0. 0 cents, 5 cents, 10 cents, and then it should revert back to zero when it hits 15 cents, which is what deposits the gumball. And so after this, we're going to be creating, or we're going to choose which flip flop we're going to go with. In this case, we are using a T flip flop. So it's going to have the transition table that looks like this with the state codes right here: 00, 01, 10, 11, and the input for T, which are going to be 0, 1, 1, and 0. And so after this, we're going to be creating a state table. And right here, we're going to start off with the present state. We have the state name, which is A, B, and C, because we only have three states, and each state has two arrows. And so then we're going to have our state codes, Q1, Q0, and then we have our input, which is going to be the nickel. And then we're going to have our next state with the state name, the state codes, and the difference is going to be that this one is going to have an output, which is going to be Z. And after that, we're going to have our required flip flop inputs, which is going to be T1 and T0. And so after this, we're going to be creating a K map, which should look something like this. We're going to have our Q1 and then our Q0 with the N, which is nickel. And so from this K map, you're going to be deriving a Boolean equation, which is what I got right here. And then output, which is going to be Z right here. And we're going to use this Boolean equation that we get from here to create the next step, which is going to be the circuit to implement. And this is how the circuit should look like. We have our nickel input right here. We have our clock. We have our two T flip flops right here. We have a tunnel for Q0, tunnel for Q1. These are present state, then this is going to be our next state, and this is going to be our output, which is a strobe in this case. And then we have our state codes right here. And so we're gonna go ahead and test this circuit out. So if we were to put a nickel in while, so we were to put a nickel in right now, and the clock starts fluctuating. You can see that from low to high, it's going to be 0, 1, which is going to be 5 cents. Were it to fluctuate again, it will be 1, 0 because another nickel is being inserted, which is going to lead us to 10 cents. But if we were to stop giving it nickels and the clock fluctuates, you can see that there's no change and it's staying at 10 cents because no nickel is being inserted. And so, as such, if no nickel is being inserted, that means it's going to be reverting back to the same state that it's in. So, in this case, it's going to be 1, 0. It's going to stay at 10 cents, such as our state diagram right here. It's going back because it's an input of 0 nickels. And so this is a milli machine and not a Moore machine because a milli machine doesn't have a state that represents final cost, which in this case you can see right here in this state diagram. It doesn't have a 15 cents state because it's reverting back to its first state. And in a Moore machine, the state diagram would have a final cost and would be one extra state than it would be in a milli machine. And an output is not a function of current inputs, such as it is in a Moore machine, only of present state and not present inputs. And as you can see, this one does it for present state and present inputs, such as this. There you go. This is when you finally get a gumball that is being dropped, and it should stay at a high for at least two ticks or two fluctuations of the clock, and they should revert back to 0. It will turn on. If we were to stop giving nickels, you can see that there's no change. And so the reason for a milli machine not needing a state for 15 cents, even though it's a cost of the gumball, is because once you hit 5 cents, 10 cents, it needs to go back to its first state, which is going to be 0 cents because that's when the gumball is dropped. And then it goes back to the cycle or back through the state diagram over and over again, which is why there's no need for a 15 cents input or a 15 cents state. And so as long as you follow the 5 steps, which is create a state diagram, choose your flip-flop, either T flip-flop, B flip-flop, or a J and K flip-flop, create the write down the transition table, to help you out to help you fill out the state table, which is going to be the third step. Then from there, you create a K-map, derive a Boolean equation, and use that Boolean equation to create a circuit and implement it.